Developing an orbital diagram for elements like copper, Cu, and chromium, Cr, involves understanding their electron configurations, which are slightly unusual due to electron stability considerations. Both copper and chromium have electron configurations that deviate from the expected order because of the stability provided by half-filled or fully filled d subshells. Here's how to develop the orbital diagrams for these elements. Number 1. Understand the expected electron configuration. For elements in the first transition series, like copper and chromium, the general expected electron configuration follows the pattern. Chromium, Cr, 24 electrons. Copper, Cu, 29 electrons. For both, we fill the orbitals following the Aufbau principle, Hund's rule, and the Pauli exclusion principle, typically filling lower energy orbitals first. Number 2. Expected electron configuration using Aufbau principle. Normally, we would expect chromium, Cr, R, 4s² 3d4. Copper, Cu, R, 4s² 3d9. However, these are not the actual configurations due to enhanced stability from half-filled and fully filled d orbitals. Number 3. Correct electron configuration due to stability. For both chromium and copper, the electron configurations adjust to provide more stability to the atom. Chromium, Cr, R, 4s superscript 1 3d5. Chromium shifts one electron from the 4s orbital to the 3d orbital, resulting in a half-filled 3d subshell, which provides additional stability. Copper, Cu, R, 4s superscript 1 3d superscript 1 0. Copper shifts one electron from the 4s orbital to the 3d orbital, giving a fully filled 3d subshell, which is energetically more favorable. Number 4. Drawing the orbital diagrams. Chromium, Cr, orbital diagram. 1. Write the configuration, R, 4s superscript 1 3d5. 2. Draw the orbitals. 3d subshell, 5 orbitals, draw 5 boxes to represent the 5 3d orbitals. Since chromium has 5 electrons in the 3d subshell, place 1 electron in each box with parallel spins, following Hund's rule, which maximizes unpaired electrons. 4s subshell, 1 orbital, draw 1 box for the 4s orbital, and place 1 electron with an upward spin. Diagram. 3d. 4s. Copper, Cu, orbital diagram. 1. Write the configuration, R, 4s superscript 1 3d superscript 1 0. 2. Draw the orbitals. 3d subshell, 5 orbitals, draw 5 boxes for the 3d subshell. Since copper has 10 electrons in the 3d subshell, place 2 electrons in each box, one with an upward spin and one with a downward spin, representing a fully filled 3d subshell. 4s subshell, 1 orbital, draw 1 box for the 4s orbital, and place 1 electron with an upward spin. Diagram. 3d. 4s. Summary. Chromium, Cr, the orbital diagram shows 1 electron in the 4s orbital and 5 unpaired electrons in the 3d orbitals, resulting from a half-filled 3d subshell. Copper, Cu, the orbital diagram shows 1 electron in the 4s orbital and 10 electrons in the 3d orbitals, resulting in a fully filled 3d subshell. These configurations reflect the stability preferences for chromium and copper, resulting in deviations from the typical order of orbital filling.